Awesome, just a little FishingROV update. Just been playing with the idea of using the signal generated from the ESC as a way of designing the actual RPM of the motor. So I've got a bit more to learn about these three-phase brushless DC motors and the signals that drive them. So this is the signal coming from it's a combination of the signal coming from the ESC and also the back EMF. So as the motor's spinning, one of the phases is switched off at all times, and apparently the ESC listens to the signal on that phase during the off cycle to know the direction it's spinning. And I'm also wondering if they know the speed of rotation as well, because obviously it knows when it's stalled and turns back into a restart mode. And there also seems to be a strong correlation between the frequency of rotation and the frequency of the signal. I'm just wondering if there's any slippage in the motor. You know, if you load it down, the signal is definitely changing. I'm just wondering if that signal is directly proportional to the RPM of the motor. Quite interesting little beastie. So we turn it up all the way. Say the frequency increases, and then there's no PWM, and then when you turn the power down, the frequency reduces, and it also starts having more off time for the motor, so it's turning the power down by puffs with modulation within that signal shape. Got lots to learn. Yeah, I haven't got my tackle here, so I can't test it to see if it is directly proportional. And this is mainly to figure out, so when we're testing the props, we can figure out the actual speed of revolutions of the prop to get a better idea of what the pitch of the propeller does, what effect it has based on power and thrust output and stuff. So to get more data, we need to know the actual rotation speed. So that's that one, just an idea. And then I guess you hook up an Arduino or whatever. Just to listen to that frequency. Maybe you need a little filter in there just to take out that PWM noise. But it's quite fun, lots to learn. And working on a new endcap. Now this one's basically just a glue-on flange. So you glue it on with like PVC pipe cement onto the acrylic tube. Face seal. So the advantage are like it doesn't. This outside O-ring doesn't rely on the waterproofness of the print to make the waterproof seal. It's between the factory edge of the acrylic, cut an acrylic piece on the end here. So the seal is between the acrylic of the cover plate and the acrylic of the tubing, which means there won't be any printiness in the way. It also means you can preload it on the surface to get around to that low pressure problem we had with the other type that was just using the force of the insertion that would deform the O-ring a certain amount, but then that wasn't adjustable, which meant that on the surface there wasn't a huge amount of compression in the O-ring. They're getting a problem with leaks. So this one, just put a plate on there, screw it down, and then it'll preload the O-ring. And the screw is maybe a little on the shallow side. Maybe it'd be a little bit deeper, so when the pressure of the plastic squashing down on the O-ring only deforms it so far, and then the pressure is taken up by the acrylic tube and the 3D print to stop the O-ring being deformed too much, possibly getting damaged. And there also might be problems with being squashed out the way and putting pressure on weak parts of the print, fishing it. It also means that the O-ring groove is accessible. I had problems with the Elmo because it was kind of encapsulated, the O-ring within a groove, which meant it was difficult to get the O-ring out and difficult to clean the groove. But this one should be dead easy. Pop the plate off, take the O-ring out, give it a wee clean, put the O-ring back in, Bob's your auntie. And also it should be possible to double O-ring seal this. If you print another one of these, basically just kind of opposite, that you glue on the inside, and the O-ring will be against the factory face, the inside of the acrylic here. So one here and one here, and just to double your chances. The one on the inside will rely on the waterproofness of the 3D print, so it might not be quite as effective as the outside one. So we'll see, lots to test, which is great. And I've also been working on the Kickstarter, so that's to launch in the next couple of days. And I would really love to do this stuff full time. So that's the plan. Fingers crossed. Anywho, stay tuned.